We're on unit 3.2 today. Okay, so unit 3.2, and what we're working on today is simplifying exponents. So simplify exponents. Simplify exponents. And your instructions are always going to tell you to leave answers in exponential form. Leave answers in exponential form without negative or zero exponents. So we want answers in exponential form, but no negatives and no zero exponents. Now, if something is like to the second power, like a number to the second power, you can actually multiply that out. You should know that. Okay, so anything that's squared, so meaning to the second power, or cubed, which means to the third power, you do actually have to multiply that out. So if you have like 2 to the third, you have to actually write that it's 8. Okay, you can't leave those in exponential form, but the bigger numbers you can leave in exponential form. Okay, so for number 1, if I give you 7 to the 4th times 7 squared. Square is the exponent of 2. 7 to the 4th times 7 squared. There is a rule in math that tells you it's actually the product of powers rule. And this tells you that if you are going to multiply with the same base, okay, and in this case the base would be 7. So if you're multiplying with the same base, what you need to do is keep the base, so keep the base the same, and add the exponents. Okay, so keep the base the same and add the exponents. And the reason is, essentially 7 to the 4th is 7 multiplied by itself 4 times. 7 to the 2nd is multiplied, 7 times 7 multiplied by itself twice. Okay, so keep the base the same, the base still stays as a 7, and just add the exponents. 4 and 2 gives you a base of, an exponent of 6. Okay, so do not multiply those together and tell me that it's 49. Do not multiply those together. Okay, now I'm going to show you a little kind of an aside. What if I gave you something like negative 2 times negative 2 to the 4th? Is that different or the same? What is the base that we're dealing with there? The parentheses and the negative 2. Okay. What's the exponent on this first one? There's really an exponent of 1. So if you were to multiply those together, the exponent would be 5. But where people make a mistake is that negative 2 part. If it's in parentheses, the parentheses have to stay there. Okay? That is very different than this. Okay? It's a different thing. There's a rule with exponents to say exponents go with what's below them. Here, the exponent would go with everything inside the parentheses. Here, it just goes with the 2. Okay, so make sure if it's in parentheses, if your base is in parentheses, keep it in parentheses in your answer. There's a homework problem just like that. You want to make sure that you all understand it. Okay, let's try second one, number 2. 3 to the 5th power raised to the 3rd power. So 3 to the 5th cubed. Cubed is exponent of 3. 3 to the 5th cubed. Okay, there's another rule here, and it's basically a power to a power rule. Okay, the rule is if you have power to a power, there's a power to a power, you will distribute the exponent. And when you distribute the exponent, you keep the base the same, but multiply the exponents. Okay, so keep the base the same, but multiply the exponents. So the base is still 3. 5 times 3 gives us an exponent of 15. And that's the answer that we're looking for. So 3 to the 15th power. Next kind of problem that you're going to see is going to look something like this. If you have 6 to the negative 2 raised to the 5th power. 6 to the negative 2 raised to the 5th power. Now, we're going to use the power to a power rule, and you want to actually multiply these together. So 5 distributed to the negative 2 is going to give you 6 to the negative 10th power. But I told you that we can't have any negatives in our answers, no negative exponents. So there's a rule about how we deal with negative exponents, and the rule is that you need to move negative exponents, to opposite side of the fraction bar. Move negative exponents to opposite side of fraction bar to become positive exponents. Okay, so anytime you have a negative exponent, we're going to move whatever it's attached to the opposite side of the fraction bar. Now in this equation, in this problem, is there a fraction bar? It's invisible, exactly. So if you have a whole number, you can make it into a fraction by putting it over 1. Okay, so now it's a fraction. Now you know just to take anything attached to a negative exponent and move it to the opposite side of the fraction bar. So if you had a fraction bar, now you'd have 6 and it becomes a positive 10 exponent on the bottom. What's left in the top? A 1, okay? Because technically, could this be 1 times 6 to the negative 10th? The 1 doesn't matter, okay? But there's still something left behind, okay? You can't just completely forget that it's a fraction, okay? So you do have to leave something behind, and it's not a 0, okay? Not a 0. So 1 over 6 to the 10th is the answer we're looking for. Okay, let's combine a couple of rules. How about 2 to the 4th times 2 to the 0 power times 2 to the negative 11. 2 to the 4th times 2 to the 0 times 2 to the negative 11. So there's a couple different ways we could do this, okay? You could combine all the exponents first, or we could move this negative exponent, okay? But before we do that, there's another rule about 0 exponents, okay? Anything, numbers or letters, so variables or numbers, anything to the 0 power equals, does anyone know? Anything to the 0 power equals 1. Okay, it does not equal 0, it equals 1. So here, 2 to the 0, we don't even have to deal with it. It reduces away, and that's equal to just 1. Okay, so really this is 1 times 2 to the 4th times 2 to the negative 11th. Okay, we're going to combine the 2 because these have bases that are the same. So this will become 2 to the negative 7th power. Just add together those exponents. Then we can't have answers with negative exponents, so make a fraction bar over 1. And then you can move 2 to the negative 7th to the opposite side. So in the denominator, you're going to have 2 to the 7th. In the numerator, there's still a 1. Okay, something has to hold the place there. And that's it. Now, 2 to the 7th, you do not need to simplify. I don't expect that you know what 2 to the 7th is. Okay, anything to the 2nd or 3rd power, you do have to simplify more. But anything above that, I'm not worried about it. Yes?
What is that one with like a blue?
This one, you're not going to have to deal with this. Okay, so they're always going to be the same base or multiplied by 1. And the 1 doesn't change anything. Okay, let's try a couple more for number 5. Again, we just want to simplify. Okay, so simplify for number 5. If I give you 3x to the negative 1 over y to the negative 2. 3x to the negative 1 over y to the negative 2. Okay, anytime you have negative exponents, we want to move them to the opposite side of the fraction bar. So the y is going to move up to the top. The The x moves to the bottom. What happens with the 3? Does anything change? It stays there, okay? It stays on the top, okay? Remember that exponents go with what's below them. Exponents go with what's below. So in this case, what's below that negative exponent is just the x, not the 3. So the 3 stays there. Now, these are basically going to switch places. So you're going to have y to the second on the top over x to the first. Now, if you write just x or x to the first, doesn't really matter. It's the same answer. Okay, but you do not have to write that exponent of 1 there. It doesn't change anything. Try another one for number 6. I want you to simplify in parentheses 3a cubed, cubed is an exponent of 3, to the negative 2 power, over a cubed, a to the negative 3rd power, b to the negative 3rd. So 3a cubed to the negative 2 over 3 to the negative, or excuse me, a to the negative 3, b to the negative 3. Now, before, if you remember PEMDAS, you guys remember parentheses, exponents, multiply or divide, add or subtract. Okay, you always have to do what's inside the parentheses first, and then the exponents. Okay, so multiply, divide, when you reduce things, that's actually dividing. Okay, that's multiply or divide. You cannot do that until we've taken care of the exponents. So here, this exponent needs to be distributed. So this negative 2 goes to the number and the letter. But remember, it only goes with what's in the parentheses because it goes with what's below it. What's on the bottom does not count. You do not put those together. Okay, so if I rewrite those, you're going to have 3 to the negative 2, a to the negative 6, because power to a power, they multiply, over a to the negative 3, b to the negative 3. Now, before you cancel anything out here, you can only cancel when you have positive exponents. Okay, so if you have negative exponents, do not cancel anything yet. I'm going to rearrange and put all the things with the negative exponents on the other side. So this whole problem is going to flip over, and in the top you're going to end up with a to the 3rd, b to the 3rd, over 3 squared, a to the 6th. Now that you have positive exponents, now we can reduce things. Okay, they can reduce away. If you had 3 a's on the top, 6 a's on the bottom, the ones on the top can reduce away. They just go away. And you'll end up with 3 left in the denominator. Now, technically, these reduce to be a 1. If you write 1 times, that's fine, but you don't have to. Okay? In the top, you still have b to the 3rd. And in the denominator, I don't want you to leave it as 3 to the 2nd because you actually know what 3 to the 2nd is. So that would be 9a cubed. So b cubed over 9a cubed. Okay, for number 7, let's try another one. How about, in parentheses, x squared over y raised to the negative 1 power multiplied by, again in parentheses, x over y cubed squared. X squared over y raised to the negative 1 power multiplied by x over y cubed squared. Now remember, please excuse my dear Aunt Sally. Multiplying these together, that's multiplication division. First, we have to take care of the exponents. So to take care of the exponents, this one distributes, goes to everything inside, so the top or the bottom, numerator or denominator. Same thing here. Distributes to everything inside. Okay, if you rewrite that, that's going to give you x to the negative 2, power to a power we multiply, over y to the negative 1 times x squared over y to the 6th. Okay, y to the 6th.